Hello everyone, this is Mr. Widmeyer and I am here to show you how to do all the problems from part B in the AP Calculus summer review packet. Again, we went over some of these in class, but this will give you a more detailed kind of explanation. Alright, so in letter B we are asked to simplify each expression in order to obtain a single fraction. Show all work. Okay. So, for example, right here, we can see that we have two fractions and they are being subtracted, right? So, how do we combine two fractions if we're subtracting them? What do we need in order to combine two fractions if we're subtracting? In order to add or subtract two fractions, we need common denominators, right? And so let's take a look at our denominators. This denominator here is x plus h. This denominator here is x. Now, what we cannot do, right, is add h to the numerator and denominator. Okay, there's no, that's not correct math, right? When we add to a fraction, right, you don't add to the numerator and add to the denominator. That's not how fractions work, right? To add to fractions, you have to have a common denominator, but this would have a denominator of h, this would have a denominator of x, and so they really couldn't combine like we want to them. So what do? Well, we multiply to get common denominators, right? So we can look at this denominator here and see that it has an x, but what doesn't it have? Well, if you look at this denominator, it has an x plus h. So this denominator here is missing this x plus h. So we're going to fix that by multiplying the top and bottom by an x plus h. Okay. Then what is this denominator missing? Well, you might think to yourself, well, it's not missing anything, right? Because it already has an x, like this one does. But this is an x plus h, right? Because of that addition, we treat this as all one term, or not one term, sorry, we treat this as one quantity there. Whereas this x here is a unique quantity because it doesn't have the plus h. So in other words, we have to multiply this fraction by an x over an x. And what is that going to result in? It will result in x over x times x plus h minus, and again, we'll just distribute the 1 there. X plus h over x times x plus h, like so. You could multiply the denominators out here if you really wanted to. I would discourage you from doing that. And the reason why is because, well, they're already factored. And so if we want to maybe try and simplify later, why multiply it out only to factor it one more time later on? So leave it factored like this. Okay, it's rare that you'll actually need to multiply out the denominators like that. So now let's subtract. So when we subtract here, be careful. Okay, this subtraction sign, it distributes both to this x and to this h. So we're going to end up with this x and this x canceling because we're subtracting them. So we'll just have a negative h over x times x plus h there. All right, and then this is our final answer. We can't really simplify any further from that. So there's our answer. Okay, and this next one here, technically, I guess you might say we have a single fraction, right? Because there's our fraction bar, but we really don't like having fractions with n fractions like that, okay? So we're going to fix this, all right? And then we're going to do that by, well, there's a couple different options here. Let's first of all tackle this denominator here, where we have 1 take away 2x. Let's go ahead and get those two unlike terms together. So we'll do that by getting a common denominator. So multiply that 1 by an x over an x, because it's going to 1 over 1, and we need this x denominator here to combine with this fraction here. So we'll have 4 over x plus 1 all over x minus 2 over x. Okay, now we have that common denominator, so we can go ahead and just say this is x minus 2 all over x, like that. Now, we have a fraction divided by a fraction. Is another way to think about this, right? And so instead of dividing by a fraction, what can we do instead? We can multiply by the reciprocal. So instead of dividing by x minus 2 over x, we can multiply by x over x minus 2, like so. And then just multiply together. Again, it's up to you if you want to distribute these two terms together, but not necessary. We'll just leave it as 1. All right, so there's our answer. And then finally, number 3. Number 3, okay, if we look at this one, a couple options here about what we can do. So you might even wonder, like, wait, where's the fraction, right? There's no fraction here. Well, be careful. We have this negative 1/2 exponent here. And so if I were to rewrite this, you could think of this also as x plus 1 to the 1/2 plus x, because the 1 times the x there, right, would be in the numerator. Only this x plus 1 is being raised to the negative 1/2. X over 2 x plus 1 to the positive 1/2, right? When you have a negative exponent, that means it can go down into the denominator there with the 2. Okay, and now you can kind of get an idea about our fractions here. So again, we're adding what we need to add fractions, common denominators. Okay, so this denominator, what's its denominator? It's just a 1. So we're going to multiply this one by the denominator of this one here. So just 2x plus 1 to the 1/2 over 2x plus 1 to the 1/2. Okay, so what do we get? I'm going to kind of go and we'll go down here. So from there, we're going to get 2 when I multiply the 2 here with this. But then x plus 1 to the 1/2 times an x plus 1 to the 1/2. When you multiply two numbers that have the same base, what do you do with their exponents? You add them. So it's just going to be x plus 1 to the 1 over, and then this will multiply with 1. So it'll be 2x plus 1 to the 1/2 like that. You can see it was unnecessary to do the 2. Oh, no, I'm sorry. We got the 2's there. Yeah, never mind. 2's there. So then that's that. Okay, we can kind of get rid of that 1 now because it's just the first power. And then we have plus x over 2 times x plus 1 to the 1/2 like so. Common denominators. Now we can combine our numerators together. We'll distribute the 2, okay, like that. So we really have 2x plus 2 here, and we're going to add an x. So we end up with 3x plus 2 over 2 parentheses x plus 1 to the 1/2. Now there's an alternative way to do this problem here where we could have used GCF. So since these have the same base, right, of x plus 1, we also could have factored out an x plus 1 to what power, though? Remember when we factored out GCF, we were limited by the least power, the smaller power. Well, negative 1/2 is a smaller power here, so we're going to factor out a negative 1/2. Okay, now bear with me here. If I take an x plus 1 to the negative 1/2 out of this, it means I'm dividing it out. So I have x plus 1 to the 1/2 divided by an x plus 1 to the negative 1/2. We're going to subtract the exponents. So it's going to be 1/2 minus a negative 1/2, which is the same thing as plus positive, which gives us just a 1. So this will become just x plus 1 to the 1 plus, and so now we'll take the x plus 1 to the negative 1/2 out of this. Well, that's just going to get rid of that, and we're left with just 1/2 x, like so. Okay, we can drop the parentheses here because it's just to the first power, and then just combine like terms. So x plus 1 to the negative 1/2, and this will be then 3/2 x plus 1, like that. Or if I put this negative exponent in the denominator, it would become 3/2 x plus 1 over x plus 1 to the 1/2. Now you might look at this and say, wait a minute, these two things are not the same. Well, they are actually. If I were to pull a 1/2 out of this numerator here, that would leave me with a 3x plus 1/2, and then x plus 1 to the 1/2 like that. And then we can just rewrite this as 3x plus 1/2 over 2x plus 1 to the 1/2, right? This is just a product here, so I can bring that 1/2 kind of like out front, and then the 1 would just multiply with that, and the 2 would just multiply down there, and that's where that 2 comes from right there. Okay? So there's our answer. Same as what we had over here. All right? Two different ways to do that one. In the next video, we'll look at letter C.